In the last video, I mentioned that I'll show you how to install the add-ins to get data analysis and solver add-ins. So these are instructions for if you're using a Mac on how to get these add-ins. So for if you're using a Windows computer, on Windows, if you're using Excel, then usually under File over here, you get an option of Excel options, and from there you can go to add-ins. It's similar to the example that you have on Easy Excel, but for Mac I found it was under Tools, Excel add-ins, and then these were unchecked, so go ahead and check Analysis Toolpack and Solver add-in. Okay, and that gives you both data analysis and solver under data. Okay, so in this video we're going to create the descriptive statistics table, complete this table over here, find the portfolio returns, and then find the average returns and risk, and assign weights for each of the stocks, and then calculate portfolio returns. We'll do one more thing is when we're assigning these weights, we're going to use solver to find out which weights on these stocks are going to reduce our risk, right, or minimize our risk. Okay, so let's start. First, we are going to create the descriptive statistics for stock prices. And the descriptive statistics, if you choose the option to get statistics data or some statistic information, it can give you the max, min, average, mode. Okay. So again, input range. In this case, we won't create the descriptive statistics for the returns, but instead for the prices. Okay. All right, so we have the range, labels in first row. Select your output range. I don't want it there, I want it right below the correlation matrix. So add that. Okay. I already did this example once before making the video, so that's why my box was checked. If not, then check the box summary statistics if it's already not checked. There are other things that you can do. You can find the confidence level of the mean, so that means you can, if you choose 95%, so 5% above and 5% below what the median shows, the mean should be. You can work out the percentiles. We'll just leave it simple for this. Okay. So there you go. You have for Microsoft, McDonald's, and Bank of America. You have the averages, so the standard deviation talks about your, or tells you how dispersed your data is from the mean. So the higher the standard deviation, the more dispersed your data is. You also have the sample variance, kurtosis, and skewness. These are measures for, so if you find the distribution of stock prices, it's usually like a bell-shaped curve, and these are properties of that bell-shaped curve. So skewness, usually if your data is unskewed or there is no skewness, then your skewness measure would be 0. But stock prices usually have a positive skew to them. Then you have your range, that is the range, the difference between the highest, like the minimum, and the maximum. So you can see the maximum minus the minimum, that's your range. And then you have the sum and count too. Okay, so we have the descriptive statistics. Now let's work on getting the average returns. So next we want to find out on an average, how much does Microsoft pay each week, how much does McDonald's pay each week, and then what's the return for, weekly return for Bank of America. So if you want to calculate the average, it's simply the average. And then we're going to go ahead and select all the returns. There you go. Now we have the average return for McDonald's, average return for Bank of America. So it looks like Microsoft pays 0.05% weekly on an average, whereas McDonald's pays 0.2%, 0.5%, 0.2%, and 0.2%. Okay. So this is an measure for return. So if we want to know how much does Microsoft pay, or what is the return for Microsoft, the weekly return is 0.5%, right, or 0.005. Standard deviation, that gives us information about the risk, because the more dispersed your returns are, the riskier that stock is. That is, one day if you are getting very high returns, the next day it falls drastically and then it goes up again. So there's a lot more volatility. Investors don't know what is happening to those prices. You can't sort of, you are less able to understand the trend that the prices are following. So the higher the standard deviation, the higher the risk of that stock. So to calculate the standard deviation, you can use the standard deviation function. You'll see that there are many different kinds. This difference, we're going to be using the standard deviation of a sample and a population. You only use standard deviation of a population if you have all the data, all possible data from when the stock was issued till the eternity of time, like the stock will exist. We don't have that kind of information. Like, we would be very rich if we had that kind of information. So it's a sample. Technically it matters, but the difference between standard deviation for a population and the standard deviation for a sample is one is divided by n, the other is divided by n minus 1. If you have a large enough data set, your numbers are going to be very close to each other, whether you use sample or population. This really matters when you have very small data set. Like if you have 3 or 4 observations, it'll really matter whether you're using sample or population. It's going to change your standard deviation measure drastically. But if you have a large data set, beyond some point, it doesn't matter. But technically we want to be correct, so we'll use standard deviation for a sample. Okay. Same thing, select Microsoft, shift control down, selected all Microsoft return, and then we can drag this for McDonald's and Bank of America. Okay, so we now have some return and risk information about Microsoft, McDonald's, and Bank of America. If we look in terms of risk, it looks like Bank of America has the highest volatility and higher risk in terms of volatility compared to Microsoft and McDonald's. Usually higher the return, higher the risk. In this case, it looks like Bank of America pays lower returns, but it also has higher risk. That always doesn't hold. Okay, next let's calculate the returns for our portfolio. So when you're calculating portfolio return, the portfolio really depends on how you are investing. Right. The portfolio returns depend on, one, what you're investing in your portfolio and how much money you're putting in each one of them, right? What is the proportion of, if your whole portfolio is 100%, what percentage of that is invested in Microsoft, what percentage of that is in McDonald's, and what percentage is in Bank of America. We don't have any control on stock prices. Therefore we don't have any control over these returns. But we do have control over where we're going to invest our money in and how much we're going to invest. Okay. So let's go ahead and calculate those returns. So first, what we have control over is the weights that we're going to assign to each one of these stocks. Obviously, the weights need to add up to 1. So we're saying we're investing 100% of our money in Microsoft, McDonald's, and Bank of America. to start off, we're going to assign equal weights to each one of them. So 0.33, 0.33, and then this will equal to 1 minus some. You can just assign 0.34, but this is just easier when you play around with the numbers. Yes. Okay. So we're saying we're going to equally invest in Microsoft, McDonald's, and slightly a little bit more on Bank of America. Okay. So let's calculate the portfolio return. The portfolio return, again, is going to depend on the stock returns, and it's going to depend on how much money we're putting in each one of those stocks. If we put more money in Microsoft, then our portfolio will be more correlated with Microsoft, right? So if we put like 90% of our money in Microsoft and the remaining 10% in McDonald's and Bank of America, then our returns for the portfolio will follow closely with Microsoft because that's where majority of our money is tied in. So when we're calculating portfolio return, it's actually a weighted average of these stock returns, and the weights are how much we have invested in each one of them. So if you invested more in one, then it will receive a higher weight because your portfolio returns will be more similar to that particular stock's return. So to calculate the weighted average, what we can do is we can use sum product. So sum product, what it does is, in this case, it will take Microsoft return, multiply it with Microsoft weight, take McDonald's return, multiply it with McDonald's weight, and then Bank of America's return times Bank of America's weight, right? And then take those products and add over them. When we are using it, you can first select either one of the arrays, but just make sure that your orders are correct. So in this case, we have Microsoft, McDonald's, Bank of America, Microsoft, McDonald's, Bank of America. If the order was different, if this was Microsoft, Bank of America, then McDonald's, and here it's the same, then it would not work, right? We would be multiplying Bank of America returns with McDonald's weight. So the order needs to be exactly the same. Okay, so first choose one of the arrays. You can either choose return or weight, and then enter. The same thing, next week, it's going to be a weighted average of that week's returns and these weights. Okay? If I double click this was not going to work because now it's taking a sum product of these and the row below. It just moved one row down. What we need to do is, sorry, not this one, this one, we need to use absolute reference. So select this and then function F4. So bling it, that's what I like to say. Put dollar signs before both both the column and the row. So this is going to fix these cells. Now we can go ahead and calculate these returns. So if you see this, now it's taking a sum product of the second week's returns and the same weights. Okay. So now we have our portfolio return. Let's see how our portfolio is doing in terms of average return. So there you go. So the average return is 0.336. In this case, it's almost average of the stock returns because we have put equal weights on them. If you decided to give more weight here, so 0.9, and let's say we did 0.05 and 0.05, you can see the returns are more similar to Microsoft. Right? You can go to the extreme, put 0.99 here, 0.001, the returns are even more similar to Microsoft. All right, let's go back. You can also calculate the riskiness of your portfolio using the standard deviation of the portfolio returns. So you can see the riskiness also is in between all this. The coolest thing about this is that when you are holding two stocks, that have a correlation below 1, I mean, it could be very close to 1, it could be 0.90, you'll find that the portfolio's risk is going to be lower than your riskiest asset. That's because if one stock price falls, maybe when Microsoft fell, McDonald's also fell, but not as by as much, right? So if you had see this day for instance, all the stocks reported negative returns. Maybe the market fell that day, but McDonald's had a 4% drop, whereas Bank of America had 2%. Oh, sorry, I'm using the wrong. So this one. So it looks like Microsoft's stock returns did not change by as much. The price is the same. So this one did not move, whereas McDonald's and Bank of America took a slight hit, but you could still recover some money from Microsoft. It did not lose anything. So if you had all your money in McDonald's and Bank of America, your loss would have been larger. But by combining Microsoft, you were able to sort of minimize that loss. Okay. All right, I think I'm going to go to another video to go over Solver because it's quite a long discussion. I think this is going to make this video quite much longer than I had anticipated. So let's go to the next video to see how to use Solver, this tool Solver here, to find weights for your portfolio that will minimize your risk.